Today we are going to evaluate graphs and polynomial functions. First we have to know what polynomial functions are. Okay? A leading coefficient is the number in front of the one with the leading degree. Okay? And then when you write them in order, you should write them in degree from least to from greatest to least. So what this is telling us down here is a degree of 0 is that's our linear functions, or f of x equals 5. Oh no, that's just our constant functions. Now a degree of 1 is our linear functions. A quadratic, that is our square functions, or the ones you've been working on. Our cubic are the ones with x to the third, or our powers of 3, and our quartic ones are ones with x to the fourth. So f of x to the 4x to the fourth plus x cubed plus x squared plus x plus minus 3. That is a quartic. Decide whether the function is a polynomial function. If so, write it in standard form and state its degree, type, and leading coefficient. So first, this is written in order. Okay, it is a quartic. Okay, the leading coefficient is right there. It's 1. Okay, the degree is 4. Okay, and then the type, we already said that. We already said the leading, and it is in standard form because it is from least degree to greatest. From greatest to least. Okay, this one is not a polynomial function. The reason being is because x is in the exponent area, so therefore it is not a polynomial, so not a function. What that means is it won't pass the vertical line test. Okay, this one, okay, also is not a function because of that, and that would mean that x is on the bottom. So therefore, not a function. Not a polynomial function. And the last one here, it's not in standard form yet, so we've got to put it in least from greatest to least, which would be pi x squared plus 7x minus square root of 3. And this is a function, and it is a quadratic. The leading coefficient is pi. And the degree is 2. Okay? Use direct substitution to evaluate the polynomial function for the given x value. So direct substitution is just exactly what you guys know in the past, which would be negative 2 to the fourth plus 2x plus 2, negative 2 cubed plus 3, negative 2 squared minus 7. And that would be 5. So f of, and I wrote a couple things wrong here. This should be f to the negative 2, and therefore f to the negative 2 equals 5. Okay, again use direct substitution. So we get f of 3 equals 2 to the 3 to the fourth minus 5 to the 3 to the third minus 4 to the 3 plus 8, and that equals 23. Yeah, it's a little harder because typing all that into my calculator is pretty tough. Okay, maybe I'll make a mistake. There is an easier way. Okay, and it says use synthetic substitution. Okay, we take 3 and we make this L bracket. Okay, and then we say the leading coefficient is 2. The next one is -5. There is not one for x squared, so we have to put a 0 there. There is one for x, and there's one for 8. What has to happen is this represents x to the 4th. This represents x to the 3rd. Here, let me write that in a different color. This represents x to the 4th. This represents x to the 3rd. This represents x squared, since there wasn't one, so that's why we're putting 0. This represents x, and then this one represents your constant, or your a to the 0. Okay, and then how this works is you drop the first value, okay, then you multiply it by 3, and you end up with 6, and then you add -5 and 6 and you get 1, and then again you multiply it and you get 3, and you add and you get 3, then you multiply it by 3 again and you get 9, you add and you get 5, and you multiply it again and you get 15, and 8 plus 15 is 23. So the solution of f to the 3 is 23, which was what we got on the last page, a lot quicker than typing it into my calculator. Okay, use synthetic to do this one. Again, it'd be 2, we L, and then it's 5, 3, -1, 7. All of my degrees are represented, so I drop the first one, I multiply it by 2 and I get 10, I add, I multiply it by 2 and I get 26, I add, I multiply it by 2 and I get 50, I add and I get 57. So f of 2 equals 57. Okay, and again we're going to use synthetic here. -1. Okay, and we got 2, -1, and we're going to have to put a 0 in for x squared, 4, -5. Drop the first one, multiply it by -1, drop the second one, add, and you get -3, multiply, and you get 3, add, you get 3, multiply by -1 again, and you get -3, add, you get 1, multiply by -1, get -1, add, and you get -6. And that is our solution. G of -1 equals -6. Okay, we got to decide whether this is a function, and it is. Okay, it's a quartic. The leading coefficient is pi. Okay, the degree is 4. Okay, we need to use direct substitution here. F of x equals 5, and this would be f of -1, sorry, equals 5 to the -1 cubed minus 2 to the -1 squared plus 10 to the -1 minus 15. And then you need to actually do this on a calculator or in your head. This would end up being -5 minus 2 minus 11 minus 15, and you get f to the -1 equals -7 minus 11 is 20 is 18, minus 15 is negative 33. Okay? And now we're going to do the same, we're going to do synthetic here. And we got 3, then 5, negative 2, negative 8, 16. We do not have to add a spacer because all of them follow in order. 3, 2, 1, 0. Drop that, you get 5. Multiply, you get 15. Add, you get 13. Multiply, you get 39. Add, and you get 31. Multiply, you get 93. Add, and you get 119. And then, that is your answer. F to the 3 equals 119.